Hello and welcome to revision lesson 88 of our SHS 3 physics series. In this lesson, we shall discuss the AND gate. In today's lesson, we shall solve another problem using the NOT gate before we discuss the AND gate. Let's look at the question. To keep your day-old chicks warm, you have a 100 watts electric bulb in your hatchery. This bulb is able to provide sufficient heat to keep the young birds warm. When there is a low voltage, the bulb is not able to generate enough heat to keep the birds safe. What type of alarm system would you use in the hatchery to alert you when a temperature in the hatchery falls? Right, let's look at the solution. Because the physical variable is temperature, we shall use the temperature sensor. For the output, we need a buzzer. Now, when we cease rubbing the finger on the temperature sensor, the temperature goes down so that the input of the NOT gate is low, but the NOT gate inverts the input to a high so that the buzzer sounds. So if we liken it to our hatchery, this means that when the temperature in the hatchery goes low, the temperature sensor is able to detect it and then sends an input which is low to the NOT gate, and then our buzzer sounds, indicating to us that the temperature in the hatchery is low. Now, we can also use a breadboard and discrete components to solve this problem. And in doing so, we shall require the following items. 1. A breadboard. 2. A NOT gate. 3. A temperature sensor. 4. A buzzer. And 5. Pieces of connecting wires. On your screen is a schematic diagram of the circuit we need if we decide to use discrete components on a breadboard. We have our NOT gate, and we have one terminal of the temperature sensor connected to pin 1 and a second terminal grounded. Pin 14 of the NOT gate is connected to the power supply VCC, and pin 7 is grounded. Now we have one terminal of the buzzer connected to pin 2 and the other terminal is grounded. Okay. Now let's look at the subject of our discussion for today, which is the AND gate. An AND gate has 2 or more inputs, but only one output. In this lesson, we shall limit our studies to an AND gate with only 2 inputs. The logic symbol for 2-input AND gate is shown on your screen. A and B represent the inputs and Q represent the output. The two input digital logic and gate IC can be obtained in two forms. The TTL logic types, usually with the inscriptions 74LS08 or simply 7408, and the CMOS logic types with the inscription CD4081 or simply 4081. The diagram on your screen shows a CMOS IC and gate with 14 pins. We can also use the TTL logic gate such as 7408. The diagram on your screen shows a schematic diagram of a CMOS IC and gate with 14 pins. It is a 2-input AND gate with 4 gates in the chip. For example, in gate 1, pins 1 and 2 are the input terminals, while pin 3 is the output terminal. In gate 2, pin 4 and 5 are the input terminals, whilst pin 6 is the output terminal. In gate 3, pins 9 and 10 are the input terminals, whilst pin 8 is the output terminal. In gate 4, pin 13 and pin 12 are the input terminals, while pin 11 is the output terminal. VCC represents the power supply. The positive terminal of the battery is connected to pin 14, while its negative terminal is grounded. Pin 7 is also grounded. Now, let's look at how the AND gate works. In doing so, we are going to use the decisions module, or what we also call the logic board. Now, we want to use the decisions module to demonstrate how the AND gate works and hence construct the truth table for it. So this is the AND gate on the decisions module. It has 2 inputs, F and G, and the output is L. Now we can use any 2 of the inputs: the slide switch, the push switch, the temperature sensor, and the light sensor, which has been covered so that it is not on. In this case, let us use the slide switch and the push switch as our inputs. So we connect the terminal of the slide switch to one of the input terminals of the AND gate. Let's connect the second input terminal of the AND gate to the push switch. All right. Now we need to connect the output terminal of the AND gate to one of the input devices on the board. Let's choose the buzzer. So we connect the output terminal of the AND gate to the terminal of the buzzer. Now let's look at our inputs. For the slide switch, as we discussed earlier, it has two positions. It can be at position 0, where the input is low, or position 1, where the input is high. For the push switch, if we press it down, the input is high, but if it is not pressed, the input is low. So for the current positions of the inputs, the slide switch is at position 0, therefore the input is low, and the push switch is up, so the input is also low. So there is no sound of the buzzer. Now let's push the slide switch down to see whether there will be any change in the situation. We push the slide switch down. There is no sound of the buzzer. Let's release the push switch. Now let's move the slide switch to position 1 and see what happens. The slide switch is at position 1, but there is no sound of the buzzer. Right. Now let's make all the inputs high. So whilst the slide switch is at position 1, let's push the push switch down to see what happens. We can hear the buzzer sound, meaning that the output of the AND gate is high. Now let's use this to construct a truth table for the AND gate. Now to look at it again, our initial positions, we had the slide switch at position 0, which is low, the input is low, and the push switch is up, which is also giving an input that is low. Therefore, there was no output because the buzzer does not sound. Now, we can construct a truth table for the AND gate as shown on your screen. Let's represent the inputs with A and B and the output with Q. Now, at the first instance, all the inputs were 0 or logic 0. The buzzer does not sound, so the output Q is also 0. The second step, the push switch, which is the second input, was pressed so that it is giving an input that is high, but the slide switch is at position 0, so the input for the slide switch is low. The buzzer does not sound. We can represent that also on a truth table as shown on your screen for the second step. For the third step, we move the slide switch to position 1 so that the input is high, but the push switch is not pressed so that its input is low. In this case also, the buzzer does not sound. We can also represent this on the truth table as shown on your screen. The fourth step, the slide switch was at position 1, which is high, and then the push switch was pressed so that its input is also high. And in that case, the buzzer sounds. We can represent this also on a truth table as shown on your screen. So that gives us the complete truth table for the AND gate. AND gates are used to control the progress of signals in a microprocessor. Now let's see how we can use the AND gate to design an alarm system. Thieves normally take advantage of power outages. You have just concluded your lessons on logic gates. Design a simple burglar alarm using an AND gate which can warn you anytime there is power cut and the front door of your house is open. Let's look at how we solve this problem. Now in this circuit, we need two sensors because an AND gate has two inputs. One, a light sensor. Two, a switch sensor. This can be a push switch. The light sensor will give logic 1 or high when there is power and logic 0 or low when there is power outage. Therefore, we have to pass the input of the light sensor through a NOT gate so that it will invert its low to high. The push sensor must be fixed into the door and can be arranged to give a high or logic 1 when the door is open. The signal from the two sensors can now be fed to an AND gate. The output signal will be used to sound a buzzer. Since the light sensor will give low voltage, that is logic 0, when it is dark, we have to add a NOT gate that will invert its low voltage to high voltage. The schematic diagram is shown on your screen. We have the input A representing the door sensor, and this can be a light dependent resistor which must give logic 0 when it is dark. We have our input B representing a push switch sensor which must give logic 1 or come on when the door is open. Then the input of the door sensor is passed through a NOT gate which will invert the logic 0 to logic 1 in darkness. So the two inputs are now fed to the AND gate. Now, the output must give logic 1 so that the buzzer will sound. Now, when both inputs are logic 1, then the output of the AND gate will be 1. In that case, the buzzer will sound. This demonstration on the decisions module will be done on the next shooting. Now, apart from using the decisions module, we can also implement this circuit using discrete components on a breadboard. On your screen is a schematic diagram of how the circuit will look like if we use discrete components on a breadboard. As you can see on your screen, we have two gates, the NOT gate and the AND gate, which we are going to use. And so what we will do is that we are going to fix these two gates across the bridge on the breadboard as we usually do. So having the light sensor, we are going to connect one terminal of the light sensor to pin 1 of the NOT gate, and we ground the second terminal of the light sensor. Now, we are going to also ground pin 7 of the NOT gate, and then connect pin 2 of the NOT gate to pin 1 of the AND gate. Now we are also going to connect one terminal of the push switch sensor to pin 2 of the AND gate and then ground the second terminal. We also ground pin 7 of the AND gate. Then we connect one terminal of the buzzer to pin 3 of the AND gate and ground the second terminal of the buzzer. Then we shall connect pin 14 of the NOT gate and then pin 14 of the AND gate to the section of the breadboard where we are going to connect the power supply. Now when we are done, we shall then connect the positive terminal of our power supply to the top row on the breadboard where we have connected the pin 14s of the NOT gate and the AND gate, and then connect the negative supply to the bottom row on the breadboard, which represents the ground. So looking at the diagram on your screen and with the explanation received so far, try implementing this on a breadboard as an assignment. Well, viewers, we have come to the end of our lesson for today. Till we meet again for the next lesson. Goodbye.